Hello, everyone. Today's session focuses on effective context engineering for AI agents. We are mainly going to talk about the strategies of curating and managing the effective context for the AI agent. This presentation is based on a recent blog published by Anthropic. This blog is published end of September. It's on effective context engineering for AI agents. This blog mainly talk about the context, right? It's actually a very valuable and critical finite resources for AI agent. And then in this blog, they talk about different strategies of how to effectively curate and manage the context that power AI. And whenever we talk about the context, usually any AI API or LLM, they comes with a context window in terms of like how many input tokens or output tokens can be included in total for the LLM. For example, for the GPT-4o, the context window is like 128K. Like a more recent release of GPT-5 is 400K. Cloud 4.5 is 200K, I think, by default, but it also can support up to 1 million context window token using the API for the big enterprises. The Gemini 2.5 Pro is 1 million. I also heard that they're also going to support the 2 million next. So this is the context window. It's like the maximum number of tokens that the LM is able to handle. But this article or this blog is more than that, than what is the upper limit. It's more like what are the best kind of strategy to select the most relevant token to put into this context window. You may already hear or see the headline to say, oh, prompt engineering is that, right? And right now, everything is like context engineering. I would say, like, in my opinion, it's the same. So I think the prompt engineering, context engineering is the extension to prompt engineering. It is still prompt engineering, but it includes more tokens, more variety of tokens from different sources in the prompt. Right. So traditionally, when we do the prompt engineering, you can think about it like the one LLM core, right? And then in your prompt, it's your instructions to the LLM, and then you can there are some system instructions. Say you are a helpful assistant, right? And then there will be some user message. Say you ask what is the capital of France. Like that. So usually this is like how you structure your prompt to LLM to do the Q&A like in a chatbot. Well, right now for the context engineering, so basically what I mean is like it's still prompt engineering, but it's an extension to it. The context, think about like all the possible contexts you can provide to the model. It can be any document, sources of information. It can be diversified set of tools on the MCP server, or the memory of the agent, or like all the comprehensive instructions and domain knowledge you can provide to the AI. Right? So this is like all the possible information you can provide to the AI agent. But exactly what document, what tools that you want to select at that timestamp that are most relevant for the task for the AI agent, like you need to do this curation, right? To select the most relevant. Like for example, you may start with the system prompt, and then out of say 100 documents, maybe you identify only 2 documents are relevant, the RAG idea. And then you also identify, okay, what are the most relevant tools, right? I can provide to the agent instead of sending them the full comprehensive list of tools. So the key idea is, given all the possible sources of information, how can we select the most relevant instructions, sources, and tools into the LLM context window so that the AI agent can achieve the best performance, both for better performance and also for lower cost, right? Usually like the API is charged by how many tokens you use. So like if we can carefully select the relevant token, it will also save us lots of cost when calling this API. Okay, so that's what is the context engineering. So the definition of the context is basically the set of tokens included to put into the LLM, right? LLM input. And then we use this set of tokens, then start running the LLM inference. or we say, okay, we can sample the output tokens from LLM model. And context engineering is about the strategies to curate and maintain the optimal set of tokens, right? Given the pool of tokens, given all the candidate list of sources, how can we identify the optimal set of tokens for the LLM inference, right? Including all the information, like not just including the system prompts or user message, but includes all the relevant sources, domain knowledge, and tool to the LLM. And usually this can be an iterative process, especially if the AI agent is multi-turn. Usually the AI agent, is like a back and forth process. It's not like a one single LLM call. And then at each iteration, we need to figure out what is the most relevant content to provide to the AI agent each time. Okay, so that's about the context and context of engineering, what it is. Next, this blog also talks about like why it matters. What are the key issues we see when we make LLM calls? Yeah, we all know like LLM is powerful, but LLM can also lose focus and experience confusion at a certain point. It's very similar behavior to human, right? Like if you drown the LLM into lots of tokens, even though the context window can take it, the LLM can still get confused and the performance may drop. They call this phenomena as a context rot, right? So the number of tokens in the context window increases, the model ability to accurately record the information and able to answer the questions or requests accurately will going to decrease with the increase of input tokens. The message is, yes, you pay for 128, or maybe you pay for 1 million tokens of the context. Basically, that's how many tokens can be accepted by the LLM. But in the end, you may be just using 30K effectively. The rest, the model is just ignoring them. They are still charging you anyway. So that's the finding people see. And there's also some paper discussing about, what are the kind of the heavily effective tokens the LLM is using. You can interpret the curve as if the score is high, if the y-axis is high, it means that the token are utilized effectively, right? So the LLM can grab the information from these tokens effectively. But if this score is low, like close to 0, it means that the LLM can easily ignore them. So people have run these studies, and then they show that majority of the LLMs, they kind of pay more attention to the tokens in the beginning of the context or toward the end of the context, right? So it's more like this U shape. And to my surprise, DeepSeek is kind of the opposite. DeepSeek is going to pay more attention to the tokens in the middle. But anyhow, all the LLM has their preference of what tokens they are going to pay more attention to. And I believe if you are like using the GPT series model, even the GPT-3 or cloud-based models, they are going to pay more attention to the beginning of the context and also toward the end of the context. And then people also talk about, okay, how can we mitigate this, right? We already know that the LLM is going to pay more attention to the tokens in the beginning and at the very end of the prompt. And then people say, okay, can I put the most critical context and most critical instructions to the beginning or toward the end? Or maybe I can put it like both at the beginning and the end to make sure that the LLM follows my instruction correctly. So people has also done these studies, and then they say, okay, I can compare, say I put the critical instruction in the middle of the context, right? So the mid position, or I can put it both at the beginning and the end. And then the performance does improve by a lot, even if it's the same tokens you put into the context, but the position of the tokens matter a lot to the LLM performance, which is very interesting and surprising to see. So this is the context rot. The second is the LLM has a attention budget. Yeah, I think you can think about the LLM just like how humans think, right? Like even humans has like a limited working memory, right? And then LLM also has attention budget. and it's going to duplicate with each new token introduced. What is the working memory? You can take this simple example, right? Say you are driving a car, and then someone just asks you like, okay, what is 2 plus 3? You can very quickly answer is 5. So this task requires like a simple task, requires low working memory, right? It's just like a one step of thinking. What if someone asks you, what is 13 multiplied by 28? I don't think you can just speak out loud like very fast, like 2 plus 3, right? Yeah, I think you take multiple steps to reach the answer of this question. And then this task kind of requires more higher working memory. It is the same thing for LLM. So even long before the information exceeds the context window size, the transformer or the LLM capability to effectively represent or communicate this information within the window is already exceeded, right? Like even though the LLM is able to take up to 1 million, but what is the effective working memory for the LLM is already exceeded even far before reaching the upper limit of the context window. Yes, and also the current benchmark performance will not accurately capture performance over the full range of long context reasoning tasks. And people say like, if some tasks require high working memory, you need to more specifically, for example, using the reasoning model that could get you a better performance. People also has done a very interesting experiment. For example, like we want to figure out what is the final value of this variable, right? Say you have a series of variables like x6 equals a, x4 equals b, and then x0, 2, 3, 8 equals all these variables. And then, so this is like how many steps, right? Like a sequence of variable assignment. And then in the end, you want to decide, okay, after passing the variables to each other, across all these steps, what is the final value for x7? Is it A or B? So to answer this question correctly, you need to follow the steps one by one, right? And then in the end, you could answer this question correctly, like whether x7 is A or B. And then people say, okay, what is this? How the LLM is going to answer this question correctly by increasing the number of steps, right? So in the beginning, say maybe you can just start with the 3, and then x7 equals A, like maybe it's like more accurate. And then after reaching 100, like say you have 100 rows over here, and then you ask the LLM again, x7 equals A or B, and then you will see that most LLM fails. Like it's like a random guess in the end. It's going to be randomly answering whether it is A or B. So basically, it's lose track of this sequence of reasoning. Almost all the LLM followed a similar pattern, like all close around 0.5%. So 50% is kind of like a random guess in the end. The third limitation of the LLM, of course, I think it originates from the architecture, the transformer architecture. Right? We all know that the self-attention mechanisms is kind of like each token is going to pay attention to all the tokens like within the context window. And also it's like a multi-hatted. So it's like, for example, the orange is like one attention hat and the green is another attention hat. But as the context window increases, it also stretches the model's ability to capture dependencies at scale. And also this will result in like an n-squared pairwise relationship for the n tokens. So this makes the attention even more difficult when the context window is very long. This is also originates from the training process, where usually in the LLM training process, the sequence lengths are much shorter in the training process. So the LLM kind of understand the logics in a shorter context window because it's pretty common, it's more common during the LLM training process. So this means that the model could have less experience of dealing the longer context window dependencies. Yeah, so I think this mainly talk about the limitation and constraints of the LLM and why context engineering is critical to make sure that the power of our LLM can be fully utilized. And then it also suggests that based on these constraints, the thoughtful context engineering is very essential for building capable agents. Okay, so that's why we need context engineering. Then the block also introduced about the guiding principles of how can we find the smallest possible set of high signal tokens that can maximize the likelihood of your desired outcome. And so that the LM performance kind of not decaying too much when you are, like doing this multi-turn or serving, like providing like more context to the LM. So the key principle is thinking in context, right? Just consider at each iteration given any time, consider like what is the state or what is the input needed for that request. And you just providing that to the context at each iteration. It's kind of like this, right? So you have like many different sources, maybe not just this one source of input tokens. Then this is your a big pool of context window the LM can accept. You have so many colorful information in it. But to answer that one request effectively at one time, like one iteration, maybe only the blue ball is relevant to answer that request or to move to the next timestamp, right? So instead of like serving all the noisy information and there, like how about just figure out, okay, how can we reduce the balls of, remove the balls of irrelevance, like the red and yellow and green, and trying to keep as much as possible only the blue ball in your context to answer that one request. So the challenge is to find the right balance between providing the sufficient information, right, like what to put in this context window, and to respect the model's attention constraints and the working memory limit. So there are like many different components in the context, right? Like the system prompts, tools, and retrieval part. So let's first look at the system prompts. The system prompts, yeah, so this is a prompt engineering. So prompt engineering is not that. So I think prompt engineering is still alive, but it become like a one component in the context engineering, right? We need the system prompt to be clear, simple, and direct, and that present at the right altitude for the agent. For example, if you want to just provide a system prompt for the agent to define the role of the agent, right? So here is the customer support assistant for a bakery company. And then if your system prompt can get very verbal, too specific, it means that you describe all the kind of situation. It's kind of almost like a rule-based to instruct the LM how to route the user request according to their intentions, right? Like if this, do this, if this, do this. It's more like creating the rules for the LM. It's like too specific, and also that introduce lots of tokens. It may not give you the best performance, and maybe you just do it too much for the LM. Or it can be two-way, right? You just say, oh, you are just assistant and you just want to solve the customer issues without providing any additional guidance to the LM, and then the LM performance may also not be tailored to what you need. What we need for the system prompt is in the middle part, that you provide the thinking framework, right? So this is, for example, this is how I think can be helpful to resolve a customer request, right? So this is your thinking framework, like identify the issue first, and then gather the context next, and then provide a clear resolution, and then also make sure that you confirm your customer satisfaction from there. And then you can also provide more guidelines to the agent to distill more domain knowledge and domain expertise as guidelines for the AI agent. But not do this, like iterating all the rules for the LLM, not do this, and also not do this, right? Like the LLM will be confused, like what is supposed to do. The right concept is like more teaching the LLM the framework, the thinking framework, and the guidelines. And that will also gives you like a optimize the number of tokens for your system prompts. The next important in the context for agent to solve the problem is the tools. And one thinking that you should have is if a human engineer cannot say which tool to be used given situation, you cannot expect an AI agent to do better, right? If a human is confused, like, oh, like given this tool, like which tool should I use? I don't think this tool has the right description. I'm not sure whether this tool will solve this problem. then you cannot expect the AI agent can do better than human. So this is the kind of the thinking mode or principle. So you need to design the tools to allow the agent to operate within their environment and pull in new and additional contexts as they work. And then the tools needs to be very well scoped, self-contained, robust to error, and very clear in terms of their intention use. So one guidelines to creating the tools is to choose the right tools to implement. For example, instead of implementing the list users, list events, or create event, like you need to implement lots of tools. Also, the list users or list event may also return you a very long list of users, very long list of events, which may duplicate your tokens usage, right? So consider implementing just a schedule event and let the schedule event tool to figure out whether there's any conflicts and say during the same time. And also, instead of implementing a read logs, consider implementing a search log, which is more relevant for the user request, right? So this will be a good tool for the agent, like to search based on the user intention, rather than for the agent to read all the logs and then trying to reason about, which log is exactly fit the user request. And also, instead of implementing get customer by ID and et cetera, you can just like a get customer by a context. It's like a one tool that can can support all the customer ID or transaction ID or some detailed tag, and you can just all integrate it into one tool, so that you also help reduce the number of tools you can provide to the LLM. So that's the first guideline. Second is the naming of the tools. So they also mention about the name spacing of the tools. Adding the prefix or suffix can also help define the boundaries around the tools. For example, we can name the tool by service. Say it's a Sana service or a Jira service. So you can add the prefix to the tool so that it's very clear about the name spacing or the service that the tool is going to use. Or you can also add it by the resource, such as like Asana projects or it's Asana users. Yeah, so basically like they find that to name these tools correctly, or effectively by service and resource, can also help reduce the tool confusion of the AI agent, and may also save you the token usage, right? Because the tool name already stands by itself. Then the third advice to creating tool is like you should give the tool like the ability to return the meaningful context. Maybe like in your tool return, you can add a flag to say whether you want a detailed response or you want a more concise, brief response. For example, over here, like I want a detailed tool response about the dev issues, I guess, like the dev is from who, the timestamp, and what is the issue, right? Found a critical bug or a ticket, found a critical bug in the login inflow. So this tool may return a very long, detailed tool response. In order to use the token effectively, since this tool token output is going to be provided as input to the AI agent, right? You can also allow the tool just to respond more concise mode. And so that the agent can read as many messages as possible and just keep the key information and the key value pairs for the information. For example, over here, they just keep from who, and then they keep the text. Maybe that is what needed for the AI agent to resolve this issue. And then the fourth one is to optimize the tool response. The tool response, also sometimes the tool may return an error, right? You may think about, okay, how can the tool respond with the most helpful message for the AI agent so that the AI agent can decide what is the action to take at the next step. For example, if the tool returns an error, if it just returns this, like resource not found, and give a status, and then the message say invalid value, and then this is kind of the call to the tool. Actually, the LLM may take more thinking tokens, and is going to duplicate some LLM memory to figure out how to resolve this tool error. A helpful tool response will be, I can directly say, okay, resource not found because of invalid user ID. And then this is the error summary. And then it can also respond with, oh, this is the valid user IDs, right? So instead of an email name, the valid user ID should be just like ID codes. And then you should just resolve it by a user ID, like just call user search. So these are for each error, possible error message of a tool call. Maybe you should also like draft this, show an example of what is the right way to call this tool correctly to resolve this error. It will be also very helpful for the AI agents so that they don't need to do the back and forth and taking more syncing tokens to resolve the tool error issues. Yeah, and of course, the last I think is prompt engineering. Yes, so prompt engineering is definitely life. It's not that. So prompt engineering your tool descriptions, right? So you need to describe a very good, and of course, it has to be concise. I think everyone in the LM world, you need to be a good writer. I know that the LM may also automate some writing for you, but still, you need to be a very good writer and auditor of the LM output so that you can put a very concise and intentional message to describe the tool, right? The intention and what it is about. Like retrieve the current stock price and like this. So trying to provide the right guidelines. And also not too verbals, right? But still the framework and guidelines for the tool descriptions. So instead of like a very poor tool description, like get the stock price for a sticker. Like this. Yeah. So this is a summary about like how can we design the tools so that the AI agent can manage and use these tools more effectively, right? Like choose the right tools to implement and not to implement, right? If the tool is going to return like a whole world of tokens to the LM, yeah, better not use that tool, or else your LM working memory or the tech context window is going to be deprecated pretty soon. And then the namespacing, right? The naming of the tools can also important. It's better grouped under certain services or resources so that it can naturally define these boundaries between lots of tools. And also like optimize the tool responses so that the LM know exactly what's the next step to take instead of the LM, trying to reason or like what is the next step, and maybe it reason wrong, and then it will introduce lots of back and forth LM calls between the LM and the tools. So if the tool can respond directly, indicating what is the next steps to resolve the error, it will help the AI agent a lot and reduce the back and forth communications there. Yeah, and the last is the prompt engineering for your tool descriptions, just like the system prompt. It's equally important. Every single predetermined descriptions that you're going to put in the context, make sure that it's to the concise and to the as helpful as it can to humans, right? If you think that is going to be helpful for human, it's going to be helpful for the LM there. But at the same time, don't get too verbose. It's not going to help as well, like if it's too verbose or too detailized. So we have talked about system prompt, we have talked about tools. The next is the context retrieval. So the context retrieval is like on top of the system prompt and tools, right? You also have lots of, say, documents. You also have your message history, right? If you do the multi-turn, your context is going to increase there. So what is the best way to manage the longer and longer messaging history there? So the overall meta model is the just-in-time approach, right? Trying to maintain a lightweight messaging or input as much as possible, and then dynamically load the data into context at runtime using the tools rather than just keep that piece of information in the context all the time. So this is like an on-the-fly approach, figuring out what is the most relevant sources, information, or what is the relevant, say, messages from the past conversations to put into the context. This is called like an on-the-fly, just-in-time approach. Or it can also be a progressive disclosure. So just incrementally, do it in an incremental way, right? Do not try to put everything into the context window, but do it in a layer by layer so that the LM can also assemble this understanding layer by layer. We are also going to show some examples next. The third is kind of a hybrid approach, like you can retrieve some data upfront for speed. For example, the system prompt, right? Or the notebook that the agent is taking. Those are critical information that you need to keep it in the working memory like all the time. And then for the data part, you can just retrieve the most relevant on the fly at each time iteration. So it is a trade-off between the runtime exploration, because the runtime exploration is going to take time, right? Like tool calling, loading data, or running the SQL, right, to get the table. It's going to take time. While the kind of put it up front, directly storing it in the memory is going to be much faster. So it's actually a trade-off between the runtime, like you choose to store it directly in the context, or you decide to just use this just-in-time approach and to retrieve, but you need to do this calculation and retrieval processing over again, so that you can pull them back into the context. So let's look at this just-in-time approach. I'm also trying to look for the examples. And one example I found is like they talk about the Cloud Code, which seems to be the most powerful coding agent right now. For example, they use the Cloud Code to perform the complex data analysis over the large database. So the model can write the queries, store results, and level the command, like, for example, to get the head and tail of the table, right? And to analyze a large volume of data without ever loading the full data into the context. I think that this is a natural, right? If you want just to understand the schema, what is storing, or what is the information or format, you can just use the head and tail, just like a human analyst would do, right? You will never going to pull the full table and just directly give it to the LM. Like human will also get lost. So this approach also mirrors human cognition, right? We don't memorize the entire corpus of information, but we rely on this indexing system like files, inboxes, bookmarks, database, always to retrieve the minimal set of information, the most relevant information, just to reach a conclusion at one time step. The progressive disclosure is just incrementally discover the relevant context and try to assemble the understanding layer by layer. For example, at each interaction, maybe like in terms of the complexity, maybe the file size already suggests some degree of complexity. The naming conventions provide hints about what is the purpose of the tool, and the timestamps can be also used as a proxy for the relevance. So we should also so this is kind of like the overall metadata and flags you can use to help inform the next decision rather than pulling the full data there. And also the agents can assemble the understanding layer by layer. And then you should only keep what is necessary in the working memory, and then using the note-taking strategies for additional persistence. Note-taking, I see, is very common for any agent right now, because which agent you use, you are going to see some MD, like markdown file. So that's actually is a very active, managed, tuned notebook maintained by the AI, by the agent, so that the agent still have the full picture or full view about what is the key data points or conclusion has been achieved in the prior multi-turn conversations. So the hybrid approach is to retrieve some data upfront for speed and store it there, like always keep it in the working memory, and then further allow some automatic exploration at the agent discretions. So here's the example, as I mentioned, the Cloud Code agent, right? They keep a notebook called the Cloud Markdown, so MD. So if you look at the Markdown, so they say you ask it to develop some app for you, and then it's going to provide like the project overview. So this is what is the project intention, the architecture design, what is the key file, what is the workflow instructions, and the custom commands that is going to be helpful for the AI agent to choose which command or which tool to use. So this markdown file needs to be concise, human readable, and also is actually edited on the fly and tuned by the AI agent itself. And this notebook is going to be always in the working mechanism is always going to be provided to the AI agent, so that the AI agent still has the full holistic view about what this project is going to achieve, right? Instead of getting lost into like lots of multi-turn conversations. Okay, so that's about the retrieval, context retrieval strategies. They have specifically talking about how to deal with the context engineering for long horizon tasks. Long horizon, so which means that you have lots of tokens, like even if like after you do all this kind of optimizations and trying to minimize the tokens, but your token is still going to get longer and longer, right? How can we do the compression and still like trying to shorten the number of tokens in your context window? So in the Cloud Code agent, they implement this by passing the message history to the model to summarize, right? So instead of passing the full message history to the AI agent, they pass the summarized message to the agent. And then this summary should preserve the architecture decisions, unresolved bugs, and implementation details, and then discarding all the redundant tool outputs. Yeah, so this way you kind of know, like still keep track of what is the what is coding agent is going to do next, right? It will be very useful for the coding agent to make the decision about the next steps without getting lost into the tool. And also the principle is to start with maximizing the recall and trying to make sure that your compacted message try to capture as much relevant information as possible. And then you need to iterate to improve the precision. So improve precision, you just cut off all the redundancy in your tokens, right? And while still maintaining the performance of the model. But this is like trying to get the recall as high as possible first, and then think about, okay, how can I further cut off or prune the irrelevant tokens out of the context window? Structured note-taking, right? Just as I showed the cloud markdown file, it's going to be a very helpful strategies for any AI agent for the to-do list, or even each sub-agent. If you have a multi-agent system, each sub-agent can maintain its own notes file, so that the agent can track progress across a complex task. The third is the sub-agent architectures. Yeah, previously I also have the questions about why do we need a multi-agent? Why not just like a one LLM call with a set of tools and all of that? And actually, then the more I read about the limitations of the LLM, the more I think, yeah, maybe we do need multiple, like defining a more kind of a scoped, specific LLM agent. And each agent have its more fixed scope. The agent can be also a SLM, right? Since last meetup, I also talked about the small language model. So if the agent is also like a very scoped, it can be also a small language model. It's not necessarily like always LLM. Yeah, so each sub-agent, if it's like a more fixed scope, it's easier for you to kind of figure out, okay, how can I manage the working memory, right? Like how can I just manage the content more relevant for this sub-agent scope, rather than trying to make a very general agent that needs to handle lots of information. But I can just define one sub-agent more specifically for that sub-scope, so that the tokens in the context window are much shorter than a general agent. Okay, and then there's also some advantages of the sub-agent architectures. Is like for complex system, it can also allow the parallel exploration. So this is like one example of a multi-agent research system. For example, you ask the cloud AI chat, which is the multi-agent, that, for example, list all the companies in the US working on AI agent in 2025 and list at least 100 for each company, the name, website, description, what they do, etc., etc. Yeah, so if you have like a one call, imagine how many calls, like it is going to take a long time, right? Like the user may need to wait a long time to get a response. Like the agent may need to do it one by one for the 100. Well, over here is like you can have like a one lead agent, which is orchestrating all the sub agent. It can also invoke the tools. It can also run a sub-agent, maybe like one sub-agent per company or one sub-agent per specific domain, right? Like maybe like one agent for all the AI agents in legal space, one sub-agent for all the AI agents in medical or for enterprise analytics. And then all these sub-agents can run in parallel, and that will significantly reduce the response time to the user in the end, and can give you a very detailed report of each AI agent company, what they do, what is their strategy, and specifics about like what type of agent they build, etc. Yeah, cool. So that's about the agents. And I think the key takeaways is do the simplest thing. I should just start with the simple things, and then I just build that incremental complexity only when needed. Because we know that the context is critical and finite resource for AI agent, even the context window is long, but the working memory is far below the context window. So we need to make sure that each AI agent it's kind of like we need to manage all these context tokens effectively as input to the LM. And think in context, only consider what is the most relevant information we need to provide to the AI agent and think about what behavior it may yield. And can I dedicate some of these instructions to the tool directly, right? So the tool can help instruct the LLM also, so that we can also save the back and forth LLM and tool call, and also optimize the LLM performance there. And trying to find the smallest possible set of high signal tokens. For example, doing the summarization of the message history by only keeping the key information needed in your context rather than directly providing the full conversation history to the AI agent for the AI agent to reason and figure out what is exactly the next step. So that is not the best strategy in terms of optimizing tokens in a context. Yes, to handle the long horizon tasks, you need to think about the compassion, note-taking. This is commonly used in developing any AI agent, or the multi-agent architectures, right? So that you can even parallel some agentic processing to reduce the user response rate. Yeah, so the last message, I think you can just walk away with this one sentence, just simplicity first principle, and only add complexity when needed.